Hello students, this is Mr. Sims. We are in Module 1. This is the Day 7 lesson, which is on page 32 of our student books. And it says representing proportional relationships with equations. So this is a second day of writing equations for proportional relationships. Although in this lesson, we're going to focus more on how we use the equation. Back in Day 6, we just talked about how do we write it. Now we're going to talk more about how we use it. So today's lesson objective: I can use an equation to solve a problem. All right, so this is just another method. This is what I refer to as the algebraic method to solve these proportional relationship problems. It doesn't have to happen this way, but eventually you're going to get to a point in math where you're going to have to use algebra. So learning how to write and solve equations in these simpler problems will help you later on in math. So, all right, so the first example here, we got Jackson's birdhouses. So what I'm going to have you do is I'm going to have you go through and read this problem and just do your annotating on your own, but you're going to hit pause. So go ahead and hit pause and do your close reading. All right, and we're back. So going to the gist, we're going to write an equation. So there's a lot of information in here, so we've got to really pay attention to what's important. This is just fluff, just telling the story. Jackson and his grandfather constructed a model for his birdhouse. Basically, the key is Jackson can build 7 birdhouses in 5 hours. We're going to write an equation that will allow him to calculate the time it'll take to build birdhouses, assuming he works at a constant rate. Hence, nowhere in here does it say is it proportional, but if he works at a constant rate, it would then be proportional. All right, so we're going to write an equation. Remember, the steps from the previous lesson were to find K, and that does say find, apologize for my handwriting here, and then plug in K. Remembering that K is your constant of proportionality, or remember, it's just the unit rate. So we're going to find the rate of, and it doesn't specify, but time usually goes on the bottom, so we're going to do birdhouses per hour. So 7 divided by 5, I'll save you a little bit of math here, 1.4 birdhouses per hour. So that would be your constant. Birdhouses per hour. Okay. All right. So now writing the equation. So we found K. That's this part. Now we write the equation. So we got Y equals KX. All right. So that's the form. This is the general form that we talked about in class. And when we plug in K, just as a reminder, we just plug it in here. We take out the K, 1.4x. All right. Okay, so this is back from day 6, so that's just a review of the previous lesson, finding the constant and then plugging the constant in. Now it goes down to how do we use this equation to solve problems, all right? So I got 3 different ones here, so I'm going to model it 3 different times. The key to this is determining what is y and what was x, all right? So if we go back to the beginning here, when we found our constant, we had birdhouses over hours, which means that, and if you remember that K is equal to y over x, that our y is going to be birdhouses, our x is going to be hours. So in this first one, it says, how many birdhouses can Jackson build in 40 hours? Okay, so I'm going to write the equation down, okay, the one that we just made here. All right, and hours is the x. So I'm going to plug the 40 in for x. 1.4. Now, when we replace, in algebra, when we replace a letter with a value, okay, unless it's like up here where there's just a letter, if we write a number next to a letter, we assume that it's multiplication. Here, if I were just to write the 40 there, now it looks like 1.440. All right, so we have to insert a set of parentheses. We don't like to use the letter x to represent multiplication. We also don't like to use the dot because they get confusing. The x for multiplication looks like the x for your variable. All right, so then for this one, all I have to do to find y being the number of hours, which is what we want to find, Actually, you know what? Scratch that. Okay? You're going to cross that all out, and you're going to forget I even said that, because I just made a mistake if you didn't catch it already. Hours, wait a minute. Alright, actually that is right. I apologize. Alright, so this is correct. I got confused. I got confused up here. So X is hours, Y is birdhouses. We want to find how many birdhouses, so we want to find the Y. So all we have to do is take 1.4 times 40. Alright, so I'll just do that real quick. And I get 56 birdhouses. Right? So far, that's not really using any algebra. You're using the equation, but you're plugging in and just multiplying. All right, so now we're going to change it a little bit. Now it says, how long will it take him to build 35 birdhouses? All right, and here's how we can use the equation to solve this problem. So we write the equation down, the same equation, 1.4x. Now birdhouses, going up to the top, is my y. So the 35 is going to go in place of y. So we end up with 35 equals 1.4x. Right? Now to solve this, now we got to go back to, so if over here to the side, if you just remembered, you don't have to write this down, but you might have remembered from like last year solving equations that looked like this, where it was a one-step equation. You drew your line down the equal sign. When we do this later, I'm going to talk about circling the variable, and you have to undo what's being done. Well, the 3 is being multiplied to the x, so then you would know that we would have to divide both sides of the equation by 3. All right, well, look at this as reverse order. Here's my variable, 1.4 times x. To get rid of the 1.4, we have to undo it, so divide by 1.4. So then we take 35, divide by 1.4, and we get 25 hours it would take to build 35 birdhouses. Okay. All right, and just because that one's different, this one's fairly easy, but this one's a little bit different. I got another one. Now let's figure out how long it would take to build 71 birdhouses. So once again, I'm writing that equation down. This is good practice to write the equation down, and then you have to remember birdhouses, and remember it all goes back up to here. Our y was birdhouses, our x was hours. So 71 is going to go in place of y, 71, 1.4x. I'm going to do the same thing I did up above. If the number I want, if I need to get x alone, see up here, y was alone already. And that's the goal of solving an equation. So there was really no work that needed to be done besides multiplying these two together. So now here, I'm going to divide by 1.4, the same thing I did before. Right? And you get y equals, or actually, yeah, x would equal 71 divided by 1. All right, and this one actually doesn't come out nicely, but we're going to round it to the nearest tenth. All right, now this is my calculator, so it's going to look differently than what you're used to. But as far as rounding is concerned, we're going to go to the nearest tenth. Most of the problems that you'll have to solve, if they don't come out nicely, will go one place after. All right, so this would conclude this lesson video, and I apologize up here for the confusion on this problem here. All right, turning the page, this is what you're going to work on in your practice. All right, and just the only thing I want to make sure to remind you is that in this, whenever we got tables, x is the first row, y is the second row. So keep that in mind. And you're going to be writing an equation for each one. So you're actually going to split this into 2 different problems, and then you're going to find these missing values. Now there's, and I would encourage you to try to use the equation to find those missing values. All right, because it's good practice. All right, so recorded lessons, day 7 from Module 1. This is Mr. Sims signing off.